Hey guys, and welcome back to another video on the channel. In today's video we're going to be solving an application of a differential equation through related rates. Okay. Now this question has been taken from a specialist textbook from the QCAA syllabus. This is your year 12 topic as well. Okay. So let's just get straight into the question and I'll show you how to solve it. So a conic tank has a radius length at the top equal to its height. Water initially with a depth of 25 centimeters leaks out through a hole in the bottom of the tank at a rate of 5, the square root of h centimeters cubed per minute, where the depth is h centimeters at time t. Okay. So first of all, we've got to construct a differential equation where we have dh on dt, so the height at pretty much any time in the thing, and then we've got to work out how long it takes for the tank to empty. So with dh dt, what we need is two things. So dh dt, we can break that up into a chain rule. Okay, so we're going to have dh on something here multiplied by dt and that same thing there. Okay, so if these two things are exactly the same, you can basically cancel them out if you multiply them together. Okay, now let's take a look what we've been given in the question. We got given this thing here. Now we got to look at the units here. Centimeters cubed per minute. That is pretty much volume. Okay. Now everything here is in centimeters. Nothing is in meters, so you don't need to convert anything. So what we've been given here is this is dv dt is 5 the square root of h. Okay, because of that centimeters cubed per minute. Okay. So we got that there. Let's make that black. Let's move that to the side there. So we know that this unknown here is going to be dv because that's the only other variable we can see here, volume. Okay, so we know that's going to be dv and that's dv. Okay, so we've already got this one here. So all we need to do is find dh dv. Okay, now it's not going to be too hard because we know it's a cone pretty much. So we can just use the volume of a cone. Now volume of a cone, volume is a third pi r squared times by the height. Okay. Now we also got given this information. The radius length at the top is equal to its height. So in this expression here, we can actually say, all right, your radius and your height are the same. Now this is a generic version. Okay. Now we need to solve for this bit here. So this is your radius at time t. Let's just call that y. Now because your radius is equal to your top the entire time, no matter where you're at. So if you're here, this would also be y, and that would also be h. They would still be equal to one another. Okay, so we can pretty much substitute r for y, and we can just leave h as well for y. But because they're equal, we just get h is equal to y. So we can also substitute that into there as well. So if we substitute this into here, and we also substitute this into here, the volume at any given time, like this liquid here, is going to be given by this expression. It'll be a third pi y squared times by y. So we can just change it to y cubed. Okay. So the volume at any moment in time, so pretty much this blue cone here, is going to be expressed by this here, where y is the radius at time t. Okay. Now, in order to work out what we have here, actually they've got it in terms of h. So we probably actually would write this in terms of h. Actually, we'll just go h is height at time t. So instead of pretty much writing in terms of y, we'll just write in terms of h. So we'll just go volume is a third pi h cubed. Okay, because we're looking for dh dv. Okay, so we've got this expression here. And all we need to do is differentiate it with respect to h. Now if we differentiate this, we're going to get dv dh, okay? But we're looking for dh dv. So once we figure that out, we have to flip it upside down by pretty much doing the reciprocal of it, okay? So first of all, we'll start by differentiating this with respect to h, okay? So we'll have dv dh. Now differentiating this side is quite easy because all this is just a constant. You're just using the power rule on this h here. So you bring the 3 down the front. So 3 times a third is 1, so you just have pi. And then subtract the power by 1, so you just get a squared. Okay. Now dv dh is that. So that means dh dv is 1 over pi h squared. Okay. Now let's get this stuff out the way because we don't need that anymore. So we can then substitute this into our expression we have above here. So that can go there. So we'll have dH dt is equal to 1 over pi h squared times by, and what do we have up here? 5 square root of h. So 5 square root of h. Okay. So all I do is just chuck that there, and then chuck that there. Now, we've constructed the differential equation pretty much, and we want to pretty much solve it. Okay, so step 1 is construct it and then solve it as a function of h. Okay, so h and your other variable is, in this case, is t. Okay. So what we want to do is we want to separate the variables, because if we were to integrate this right now, it would be with respect to this given variable, which is t. And we can see here we don't have t's there, so we'll just be adding t's everywhere. Okay. So let's just combine pretty much this side here. So dh dt. Then we will have 5 on pi multiplied by the square root on h squared. To simplify this, we can just rewrite this bit here as pretty much h to the power of -2 times by h to the power of a half. So that's going to be positive a half, sorry. Timesing them, you just add the indices. So you're going to have h -3 on 2. Okay. So you have dh dt equals 5 on pi multiplied by h to the power of -3 on 2. And then we want to move this thing over here. So we'll have h to the power of 3 on 2 dh dt equals 5 on pi. Then what you want to do is pretty much move the dt up there. So we'll have h3 on 2 dh equals 5 on pi dt. And then we can integrate both sides, because this side here is strictly a function of h, and this side here is strictly a function of t. Even though there's no t there, it's just a constant. Okay. So we can integrate those sides independently. So this side here, you add 1 to the power divided by the new power. So you'd have h3 on 2 plus 1 over 3 on 2 plus 1. And then we're only going to add one constant to one of these sides here, because you can have one over here and one over here, but you can just merge them all into one side. So we'll just leave the plus c here. And this will just be attaching a t to it, because it's just a simple power rule. Okay. Righty. So this is going to be 5 on 2. So h 5 on 2, and then we can simplify that to 2 on 5. Okay. And then we've got this here. Now we need to plug in an initial condition to work out what this c is. Now we actually got given this initial condition at the start here because we have the depth initially. Initially means t equals 0. Depth is this. Okay, so h is 25 centimeters when t equals 0. So we can just take this stuff down below. So copy that and substitute it in. So 1 second. So then we can just chuck that 25 into here, and that's t into there. So we'll have 2, 25, 5 on 2 on 5 plus c equals 0. Going to move this to the other side and we'll make it negative. So we'll have c equals -2, 25, 5 on 2 times by 5. Then we're going to try and do this with our calculator. Okay. So first of all, you can apply the square root. So you have -2 times by 5 to the power of 5 on 5. Now because those are the same thing, you can pretty much subtract one of the powers up here and get rid of this 5 on the bottom. So you would have c equals -2, 5 to the power of 4. And then pretty much we just work out 5 to the power of 4. So 5 squared is 25. 5 to the power of 3 is 125. So just multiply that by 5. So that would be 150 plus 150 plus, actually not 150, sorry, that'd be 250. 250 plus 250 plus 125. So that's going to be 500 plus 125. So my guess would be 625. Now I'm going to double check in the calculator because I'm not going to be editing this video at all. So 5 to the power of 4, yep, 625. So C would be -2 times by 625. So that's going to give you C equals -1250, if I do believe. Okay. Now we're going to chuck that in up here. So just copy our original function here and plug in the C. So we can just chuck that in there, move that to the side, and we have -125. And then we got to work out when the tank is empty. Now, a trick is with the tank is empty is we got to look at the situation here. When the tank is empty, h will be 0, because remember h is your height or depth at time t. So if we want to work out the time when it's empty, that means we want the time when h is equal to 0. So to work out that time, you just go h equals 0. So if you chuck that into here, that term disappears. So all we're left with is pretty much well, basically this, -250 equals 5 on t. Oh, we've made a mistake here because we're going to get a negative time. Oh, I see what we've done. Okay, so back up here, remember it's leaking, right? This thing here. Now, because it's leaking, you have to put a negative sign in front of that, okay? Because pretty much your volume is going out. So that has to be a negative, which means that needs to be a negative, which then means that's a negative, which means that's a negative, which doesn't change too much at all. Actually, it doesn't change anything really. The only thing is that's a negative, and that would be a negative. So t would be -1250 divided by -5 on pi. And then we can just chuck that in the calculator. Give me 1 second because I can't do that in my head. -5 on shift pi. That's going to give you 785.39. Okay. Now that will be, what's the units for this one? In minutes. Okay. So if you want to convert that to hours, divide that by 60, and it's about 13.08 hours. Okay. Now that seems like a long time, but you got to remember, it's only leaking that much centimeters cubed per minute. Okay. Now at the start, it's going to be quite hard to pretty much leak, and pretty much because that h would be extremely large. Actually, the larger the h, the faster it will go, but the smaller the h will decrease, so then it will get slower and slower the emptier it gets. Okay, but that's how you solve this application of a differential equation. I hope you enjoyed the video. If you got lost anywhere, just leave something in the comments and I'll try my best to answer it, okay? But in the meantime, I'll see you in the next one.